Hello, hello. Hi, I hope my voice is visible properly. So, in this video, we'll see how we can create a self-signed certificate for TLS. For those of you who know what is TLS is, and those of you who don't know, I'm giving you a quick introduction on what is TLS. So, every time you visit a website, you will see there's a little key icon you will see, right? So, this is people call it SSL. Some people call it SSL, but SSL is no more. So, it's called TLS. Or transport layer security. So transport layer is basically in OSI model it sits in the layer 4. So OSI model is a 7-layer universal system or universal theoretical model that how data will be transferred from over the internet or to machine. So there are 7 layers in total how your data is transferred from binary 0101 to your application where you are seeing that these kind of data how it transfer. So transport layer sits on layer 4. So how you get this HTTPS? So that's we will implement today. So most people when think about TLS, they think about the domain name and different things like some of the misconceptions people have that okay you need to buy a domain then you will get a HTTPS. No, it's not. So we'll see how you can generate a self-signed certificate like this one. You can see there is a HTTPS logo and it's signed by organization Amazon. If you see the details, there's a lot of details showing here. So we will create a certificate like this, but our with our own details. So today's topic is self-signed certificate. Create a self-signed certificate, implement on AWS LB, and we have a VM running here, a Linux VM, which having Apache2 web server. When you open the public IP of the VM, you will see something like this. So this is the public IP of the VM. If you know how to create a VM, then it's good. If you don't know, we'll create a video about this. So this is the public IP of the VM. So if you open the public IP, Apache 2. Apache 2 is running on the VM. Okay. Now you can see there is a not secure it's showing. So means it's not secure. We are not using HTTPS. We are only using HTTP. So we need to secure this using self-signed certificate. Why self-signed? So there are two kind of certificates out there. One is self-signed certificate, and another one is CA certified. CA means certification authority. So self-signed certificate are maintained by you or yourself. You can create in any machine, in Windows, Linux machine. It's good for development purpose, internal software or anything that's used internally. But it's not good for a production application. So people uses CA certified certificate, means certification authority. Those who certify your certificate and you get the certificate so that you will see the HTTPS here. Now we'll implement self-signed certificate because don't want to buy any certificate right now. Let's start. So at first we will create a self-signed certificate. Then we'll see the certificate, what's inside it, and after that we will implement that onto the help. This is the simple VM public IP which I got by starting the VM. Let's start by creating a self-signed certificate. To do so, there is a library called OpenSSL. So OpenSSL is an open source library to create and manage certificate. We will use that library to create a certificate. So let's start. The process to create a certificate is little different. At first, you need to generate a private public key pair, we can say, with RSA algorithm. There is a different type of size out there. So at first, you need to create the key or key pair, you can say. Then you need to create a certificate signing request or CSR, certificate signing request. You need to generate one CSR file. With that CSR file, if you are doing a self-signed certificate, then you need to use OpenSSL X509 algorithm to self-signing it. Otherwise, you can provide that CSV file to the any CA certification authority. Uh, they will sign on behalf of you. But first, we will create a key to do so. Type. So this gen RSA, what it does, it generates a RSA file, RSA algorithm file. OpenSSL gen RSA. You can give the out. Out means the output file. Out, and you can give the file like file dot key and you need to give the size of the file. So there is particular size out there. You cannot give any kind of random size. So the size starts right now is 10 1024. It goes like 1024 2048 and goes 4096. So I will use a 4096 size key. So just 4096 and you can see there is a key file is there. Key file. So if you cat this one, you see this is the private key. Okay, this private key is very important. So how TLS is working, we will cover in another video. How the TLS handshake or how the HTTP is working, or when you hit a website using any HTTPS, how it decrypts the data. This private key sits on your server whenever a data HTTPS request is coming with a certificate. This private key is decrypting it and extracting the data. That's how in general it works. So right now I have a key file. So now I need to generate a CSR, certificate signing request. What it does, it consists of your organization details, your own details, and creates a CSR file. Think of it as a document which consists of all of your data. So you need to give proper details here when using production. Wrong credentials, then certification, after the certification authority signs it, it will be very difficult. So in my case, I am using self-signed, so there is no issue. So just type so, so one more thing, this is the private key file. So with this, you can create public key also. With this private key, you can create public key also. But we are not going to do that. You will just uh, generate the CSV file. Okay. Forgot to give this dash here. So when you start generating a CSV, it will ask you about all your details. So you can fill the details accordingly. So here you can see it's asking for me the one. Organization name you can give in organization you need to give your organization name. In my case, I'm not giving anything. Name, organization name. You can give anything for self and you can give anything. For production, you need to give proper values. Common name is very important when you are giving. Uh, Suppose you have a website called abc.com, so you need to give the abc.com name. Otherwise, in self-send also you need to give any kind of website name. So you can just mention abc.example.com name or anything you can give. You can also give IP address of your public VM IP. We have this public IP of this VM, but I'm not going to give that one because suppose you have a VM which does not have a public IP. So I will give just my any normal site name, and this should be at top level domain name, obviously, not a secondary domain like .com, .in, .org, something like that. A uh, top level domain name. You can give any passwords here. It's not necessary. And here. Now you can see there's a CSV file is there. So this CSV file consists of this all details what I put here. With this CSV file, now here you can do two things. If you want to do self-sign, then you need to use X509 algorithm. If you want to sign this, want to send this CSV file to a CA, they will sign on behalf of you and send you a certificate. So we will sign, so we will do a self-signing process. To do so, just so 509. So it's for self-signing, it's X509. Out will be your CRT file, certificate file. Then you need to pass sequence you're requesting the key files. So you are generating the certificates with this CSR along with this private IP, private not IP, private key file which you generated before. You are sharing all these details with your public private IP and generating a certificate. And then you need to mention the days, like how long this certificate will be valid. So I'm giving a 1 year validity. So if you enter, you see that there is a certificate file is there. If you see the file, this is the certificate. This is certificate of a 4096 bit. Now we have a key file, private key file. We have a certificate file. We are good to go. Now we will config. At first, we will configure a elastic load balancer on AWS because we already have Apache server running on port 80 on this server. This EC2. So we will create a load balancer. Before that, we need to upload the certificates to Amazon Certificate Manager ACM to fetch the details easily. So we go to AWS and search ACM Certificate Manager, which holds all your private and all your certificates. So just click here. And you can also request certificates on from AWS if you have a domain name. Request certificates from AWS. I have not done that. I created self-sign, so today just hit import certificate. Then here you need to paste the certificate details like that. This is certificate body and certificate private. For the certificate body, you need to this is the certificate. You need to send these details. You need to just copy paste this thing over there. We have pasted the certificate details here, and now it's time for key file, the private key file. Private key is very sensitive. Like that is the main thing to decrypt all of your incoming HTTPS connection. So you need to be more careful about that when you are holding the key file, the main private key file. So if you do the uh, cat key file, you will get the private key file. Paste it also there. And I've pasted it there also. So we have a certificate details and private key file details. We just do next. I'm not giving any tags here. If you wanna give any tag, like To identify all of your resources in AWS, you can mention. I'm gonna give it tags. Hit next and hit enter. You press this button, you see your certificate is upload for sumadipsite.com. This site is not valid actually, so I have given a random site because without this, your it is a mandatory thing. You need to give it in top level domain website. It's actually how many bits are there in that key. That is a 4096 bits. The lowest you can create is 1024, then 2048, 4096, and above that you can find there is a documentation in AWS. You can find it supported key size in TLS. So I will provide in the chat. Now our task is to create a LB for our VM. So let me show you my VM. So I'm in Node Virginia region. This VM is running. It's a Linux VM normal. Before creating the LB, we need to create also a instance group. Those of you know what is the instance group. It's when you create a LB, what it tries to do is that it takes the incoming request and forwards the request to all of your VMs. So uh, target group or instance group is like a grouping of all of your VMs where the LB will transfer the load. It's a round robin algorithm. So if you have three VMs, so and you get three requests, so each and every VM will get one request. That's how it works. So I need to create the target group also. In here we call target group. In GCP we called instance group. So this is the VM. So let me create a target group. Yeah, there is a target group. Use this one and create a target group. So there's a lot of options like IP address, instance, lambda function. If you have a lot of lambda functions, you can create a grouping there also. Uh, I will just do the simple instance. Give target the name I'm giving right now, and this port number is the port number which your VM is listening, not your load balancer is listening. Remember one thing: this port number is what the port number your instance is listening. So in my instance, Apache is running on port 80, so I'll give port 80 here. Now I need to choose the VPC or my net, you can say, as your term. So the VPC and protocol will be HTTP1, not 2 or gRPC. Health check is something like that. Suppose you have two VMs, and in two VMs you have two Apache servers running on port 80. So what this target group will do is that it will send a sample data to his health check to check that okay, its port is working or something like that. So that done, everything is fine. I have selected correct PPC and let's just next. So this is the right now I have only one VM is running on this PPC. That's why it's showing one. You have multiple VMs. You can select one by one by one. Port selected instance 80. This 80 will be listening on this instance, and I am including here. You can see added here and create target group. This will create a target group. After that, we can create a load balancer. So load balancer, in EC2 you will find the option here, the load balancer. So let's create a load balancer. Yeah. So now, before creating load balancer, let me show you without. I have already showed you in the beginning of the video. Without the HTTPS, how it looks. And this is the public IP of the VM, obviously. It is also not secure. So it's HTTP. There is no HTTPS. Let's get the load balancer. There's a lot of option of load balancer. I will choose the application load balancer. Other will not in this scope. Application load balancer. Hit create. Give any name. I'm giving my LB. So it's internet facing. It's not an internal load balancer. It's an internet facing. It's external load balancer, which will accept the traffic from all over the world, all over the internet. You can say that's why it will get a DNS name or Amazon cloud DNS name. It will get. It's not a. It will not get an IP. Then I need to choose the CPC. So for load balancer, you need to choose at least two subnets for better control. So I will choose these two subnets which I already have. Two region subnets, obviously, not two subnets, two region subnets for better load control, something like that. One subnet and another region subnet. Security groups, I already have configured security groups which will allow the traffic 443, 80 and RDP like 389. I am choosing this security group. And listener routing, this is important. So listener is what the load balancer will listen to. Right now you can see the HTTP port 80. So we are creating HTTPS, but right now it's showing HTTP. So we need to change it to give it HTTPS. So the load balancer will only listens to 443 HTTPS request. Select a target group. We already created a target group here. So it's this target group. So this is the listener and this is the destination. So load balancer will listens to HTTPS 443 and transfer the load to this target group, which is having 1, 2, 3, 4 any VMs. Right now it's only one VM. This is the security policy for SSL. So as we selected here, this HTTPS needs some certificates to validate. So this is the by default recommended policy for TLS. I'm not gonna change it, but if you wanna see a lot of options out there, you can go to the documentation and check. I have not discovered yet. So and this is the TLS certificate. So in load balancer, we are offloading the certificates. So what actually happening in the connection is that when you hit a HTTPS website, coming to the load balancer with encrypted data, it's encrypting here itself in load balancer and transferring the raw data to the VMs. That's how it is working. SSL offloading will work here in load balancer. So we will import the TLS certificate from ACM, AWS Certificate Manager. So there is already this one. Select here, nothing more to select, and just hit load balancer. So you'll see load balancer is created, and we'll wait for it will take some time to provision the load balancer and keep on running. When it will be running, you will get this. When it will be up and running, we can hit this DNS name. It's a record on AWS cloud. So when you hit this on the internet on HTTPS, you will see something that I will show you. Then let me reply to chat once. Still provision. So it will take some time, like 2 to 3 minutes it will take to provision the load balancer and keep on running. Let me refresh it. It's still loading. Okay. Now I can see this load balancer is active. So you can click on the load balancer name, and you can see this is the load balancer name. So if you the link basically to access your external load balancer, which can be accessible by global. So if you copy this name, load balancer name, and paste it here, normally you will see an error. Normally, it will not load. Now you can say that then what is the error? Why it's not loading? So we need to mention here HTTPS before starting it, because by default it's taking HTTP. If you hit HTTPS, but the first time it will ask you like your connection is not private, advanced, go back, something like that. But if you hit why this error is coming, let me show. I will tell you. But if you hit continue to my site, you see there is two different things. Still showing not secure. Let me open that. Open the public IP thing, and both are side by side. So both are showing not secure, but there's a difference. HTTPS. Now you can say it's showing Chrome. Why? So by default, how HTTPS works is that it will be signed by the Chrome or Edge or any kind of modern browser. Only allows HTTPS certificate from a reputed certification authority, not self-signed certificate. When you create a self-signed certificate and run on your website, you will see this HTTPS kind of thing. This is HTTP. The first thing is the HTTP, it's not HTTPS. Second thing, HTTPS, but due to its self-signed, Chrome, Edge, or any kind of modern browser will not allow you to, will show a warning that whatever certificate you are having, it certificate is not valid. Valid means it's a valid certificate, self-signed. It's not signed by an SCA certification authority, which are valid over the internet, like Cloudflare, Entrust, or any like Google have their own. So open the certificate, you will see all the details like somewebsite.com, and it's valid till 2024, and details. There's a lot of details out there. RS algorithm, click keys, this one. So these details I have provided while creating the CSR. Now certificate is there. It's still HTTPS request, but Chrome and modern browser are showing because it's not signed by any C. That's how you implement a self-signed certificate on LB load balancer. You can do the same thing on the Apache web server also, like for Apache web server running on your PM, Apache or any web server or proxy where you wanna upload your. I have implemented in load balancer because it's convenient. So that's it. That's all about this video. I think if you have any question, you can drop a comment in the video or reach out to me. That's all. This is the public IP of the VM, which is not having HTTPS, and this is the public URL of the LB, which having HTTPS. That's it. Thanks for listening. Those who are watching, thanks. Great initiative. Thanks, bye. Thanks for. If you have any question, you can drop a message or drop a comment. We'll look into TLS certificate. We will create a in the next couple of days. We will check what to do. TLS or CI/CD pipeline or anything that interests me. I don't have any plans right now to create any agenda or something like that, but we will check what upcoming in the next system. Thanks for watching. So I'm stopping the stream now. We will make a short video of this live stream and upload in someday. I'm not promising any day, but we'll post someday.